In this video, we're going to go over section 9.3 from our textbook, which is on the graphs of the sine and cosine functions. So first we'll start here with the definition of a periodic function, and it's a function that has this form here. For every real number x in our domain of f, every integer n, and some positive real number p, the smallest possible value of p is the period of the function. So here is our sine function. We saw from the last video that the domain will be all real numbers and all of our output values will range between -1 and 1. And so this is what the graph of our sine function looks like. Now this is a periodic function, and what it's doing here is called, it's oscillating. So the graph is continuous on its domain. The x-intercepts are of the form in pi, so it's a multiple of pi here, and we can see that that's the case because our graph intersects our x-axis at -2 pi, pi, 0, pi, and +2 pi. The graph is also symmetric with respect to the origin, and it's an odd function. Now, on the other hand, we have the graph here of our cosine function. We again know that the domain is going to be all real numbers, and our range is going to be all of these output values between -1 and 1. And so this is our graph here. It looks similar to our sine function. However, the x-intercepts are now of this form here. We can see that that's the case as it intersects the x-axis at these points here. And in this case, this graph is going to be symmetric with respect to the y-axis, and it's an even function. The easiest way to see the difference between these guys is the sine graph passes through the origin like this, whereas our cosine graph does not. Alright, so let's get into some terminology. So the amplitude of what's called a sinusoidal function, so those are the sine and cosine functions that we just saw, it's going to be half the difference between the maximum and minimum values. It describes the height of the graph both above and below a horizontal line passing through the middle of the graph. So for our sine and cosine functions, the amplitude is given by this here. Remember, it's going to be half the difference between the maximum and minimum values. Looking at our cosine graph here, our amplitude is going to be 1. And looking at our sine graph here, our amplitude is also 1. Now the graph of this guy or this guy here, with a not equal to 0, will have the same shape as our sine or cosine graphs, except in this case, our range is going to be this here, and the amplitude is going to be our a. Now, if we have a graph of this guy here, where b is greater than 0, it will also resemble the sine graph, but instead our period will be 2 pi over b. And similarly for our cosine graph here. So something to note here, for example, if we're just looking at our cosine function, in this case our b is equal to 1. Our period is 2 pi over 1. So we have 2 pi. Alright, so here is our procedure for sketching sine and cosine functions. So if we have the graphs of these forms here, where this is our period, we're going to start at 0 on the x-axis and mark off a distance of that period. Then we're going to divide the interval into 4 equal parts. So if we're looking for 2 period intervals, we're going to start at 0 on the x-axis and mark off a distance of this guy here on the positive x-axis. And then we're also going to mark off a distance of -2 pi over b on the negative x-axis. So in this case, we're going to divide each of those into 4 parts. And so we'll see some examples of this below. Then we'll evaluate the function for each of these x values that we just found in step 2. This will give us the maximum, minimum, and x-intercepts. Then we'll plot these points, join them with a sinusoidal curve having amplitude a, and draw the graph over additional periods as indicated in the question. So let's look at an example here, and we're going to use the unit circle to tell us the values of these guys, or the values of our function when we found our x values in step 2 here. So looking at this example here, we want to graph the function over this interval here. So this is going to be a 2-period interval. Our period from 0 to 2 pi is 1, and then from 0 to minus 2 pi is the other. So just looking at this guy, we can see that our A, our amplitude, is going to be 3/5. This is also 0.6, so we'll use 0.6 when we're graphing this. We also know that this is a sine function, so it's going to be an odd function. It's going to cross the origin like this here. So I've already divided the interval into 4 equal parts. So if we go from 0 to 2 pi, all we did here was divide that by 2. So we would get pi here. Then we would divide the interval from 0 to pi by 2, and we would get pi over 2. Doing the same thing here, we divide this interval from pi to 2 pi by 2, and we get 3 pi over 2. So that's how we'd split this guy into 4 equal parts on both sides. Now what we want to do is evaluate our function at these points. So if I were to plug in pi over 2 into our function, well, looking at our unit circle, we know that sine is going to be our y value, and sine of pi over 2 then is just going to be 1. So this means at pi over 2, our function is going to be equal to 3/5. So we said this was about 0.6 here. And this makes sense because that is also our amplitude. So we're going to plot a point right about there. All right. Now evaluating our function at pi here, we'll do the same thing. Pi is here, and our y value is 0. So in this case, we'll get 0 here. So we have a point here. Plugging in 3 pi over 2. Three pi over 2 is here on our unit circle, and our y value is -1. So we'll get -3/5 here. So at 3 pi over 2, we'll have -0.6, so maybe right about there. Repeating this process, we'll see that at 2 pi, our y value is going to be 0, so that's another x-intercept. At minus pi over 2 here, so we start at 1, 0, and we go minus pi over 2. That's the same as 3 pi over 2 here. In this case, our y value is -1, so we'll get -3/5 here. So right about there. So repeating this process, we'll see that plugging in minus pi gives us 0, minus 3 pi over 2 gives us 3/5, and minus 2 pi gives us 0 here. Alright, so now what we'll do is connect these points with our curve here. Like that there. Alright, so that would be the graph of 3/5 sine x. Alright. So we want to do the same thing now for y is equal to -5 cosine x. So we want to graph this function over this interval from -2 pi to pi here. The function is y is equal to -5 cosine x, so we automatically know that our amplitude is going to be -5 here. Now again, we have our period from 0 to 2 pi, and we split this into 4 intervals. So we divided this whole thing by 2, we got pi. We divided this new interval by 2, we got pi over 2. and we divided this interval from pi to 2 pi by 2, and we got 3 pi over 2, and did the same thing for our negative x-axis here. Now in this case, we see that we have a minus 5 cosine x, so this means we're going to have our function 5 cosine x, but it's going to be reflected over our x-axis. So we can graph it that way. However, we can also just plug in our values into our function, and that way we don't have to plot two graphs. We wouldn't have to plot 5 cosine x and then reflect it. So in this case, we want to find cosine of pi over 2. Scrolling back up to our unit circle here, cosine is going to be our x value, so that'll be 0. Doing the same thing for this point here, pi, we have minus 5 cosine of pi. Cosine of pi is going to be 1. Sorry, minus 1. So in this case, we will get positive 5 here. Repeating this process, we can plot our points here. So we saw that at pi over 2, we got 0. At pi, we got positive 5. At 3 pi over 2, we'll get 0. And then plugging in 2 pi, we'll get minus 5. 3 pi over 2 is right here. Cosine of that is going to be 0. 2 pi here, cosine of that is going to be 1. Now taking cosine of 0 here, on our unit circle, 0 is right here. Cosine of that is going to be 1. So we would get minus 5. That point there. And then repeating this for each of these points on the negative x-axis here. Minus pi over 2 is going to give 0. Minus pi will give us positive 5. Minus 3 pi over 2 gives us 0. And minus 2 pi gives us negative 5. Then connecting our curves here, we'll get something like this. All right. So get another example here. We want to graph this function, y is equal to cosine 2x over a 2-period interval, and give the period and amplitude. Well, we can see that the amplitude A is just going to be 1. Now the period in this case, remember, is going to be 2 pi over b. And in this case, b is equal to 2. So this will be 2 pi over 2, which gives us pi. So graphing this over a 2-period interval, we have our first period from 0 to pi here, and our second from 0 to minus pi. We do the same thing here. We divide this into 4 equal parts. So if we divide pi by 2, we get pi over 2. Then we divide this interval from 0 to pi over 2 by 2, we get pi over 4. And then if we divide this interval from pi over 2 to pi by 2, we get 3 pi over 2. And we'll do the same thing on the negative x-axis here. So now what we can do is evaluate these guys at these points. So we'll plug in first pi over 4 into our function. We'll get cosine of 2 times pi over 4. So here we'll get cosine of pi over 2. Cosine of pi over 2, going back to our unit circle, is going to be the x value there, so it's going to be 0. Plugging in pi over 2, we'll get cosine of pi, which we know is going to be 1. Oh, sorry, that'll be negative 1. Going back to our unit circle here, pi is here, cosine of that will be negative 1. Plugging in 0 into our function here, we'll just get cosine of 0, which we know is going to be positive 1. Now repeating this process and plugging in all of the values for these points, we'll plug in 3 pi over 4, and we'll get 0. Plugging in pi will give us 1. Plugging in minus pi over 4 will give us 0. Minus pi over 2, negative 1. Minus 3 pi over 4, 0. And minus pi will give us positive 1. So connecting these guys gives us our graph, which looks like this here. Alright, so we should all be pretty comfortable with horizontal and vertical translations. We'll see these with our sine and cosine functions as well. So a graph of this form here translates our function d units to the right if d is greater than 0, and d units to the left if it's less than 0. This horizontal translation is called a phase shift, and this expression here, x minus d, is called the argument. And on the other hand, a graph of this form here will translate the graph of our function c units upward if c is greater than 0, and c units downward if it's less than 0. So this brings us to a little bit of an addition to our procedure for sketching these sine and cosine functions. So a function of this form here can be graphed by the following. So first we'll graph our sine or cosine function with the given amplitude and period information here. Then we'll use our knowledge on horizontal and vertical translations to graph our desired function. So let's look at this example here. We want to graph this given function over a 2-period interval. So the first thing we'll do is recognize what our amplitude and period is. So our amplitude in this case is 4, and our period is just going to be 2 pi. Our b here is 1. We do have a horizontal translation given by pi over 4 here, and that in our form is given by d here. Now in this case, the form of our graph is x minus d, but here we have x plus pi over 4. So d is pi over 4, but in this case it will be negative, because we would need a negative pi over 4 in order to make this a positive. So following this procedure here, first what we'll do is graph a function of that form. So first we'll graph this guy here, and then use our horizontal translation to translate this graph pi over 4 units left. Alright, so the first thing that we want to do is divide our period into 4 intervals. We know that our period is 2 pi, so we divide it into 4 intervals, we get this here, and then this here on our negative x-axis. And then remember, this is over a 2-period interval, that's why we have it in this region and this region. So we're going to evaluate our function at these points here. So first looking at pi over 2, and remember we're graphing this guy first. So this will be 4 sine pi over 2. Sine of pi over 2 is going to be 1, so this will give us 4. F of pi here, we'll get 4 sine pi. Sine of pi is 0, so we'll just get 0 here. Then evaluating this at 3 pi over 2, sine of 3 pi over 2 is negative 1, so this will give us negative 4 here. And then repeating this process, plugging in 2 pi, we'll get 0 here. And sorry, I want to color code this. We're using blue for our 4 sine of x here. So at pi over 2 we have 4 pi over 0, and 3 pi over 2 is minus 4. And then repeating this, if we plug in 2 pi into our function, we'll get 0. At 0, we'll get 0. Minus pi over 2, we'll get minus 4. At minus pi, we'll get 0. Minus 3 pi over 2 gives us positive 4, and minus 2 pi gives us 0. So connecting these guys, trying not to make that super pointy. Okay, so we'll get that there. Now remember, this is our function for sine of x. So now if we want to graph 4 sine of x plus pi over 4, we're going to shift this entire thing pi over 4 units left. So, for example, pi over 2 here is going to be shifted pi over 4 units to the left, and pi over 4 is about right there. So we're going to need to do this for every single point here. This point here is going to shift over minus pi over 4, which is going to be about right there. So what we need to do is figure out what the rest of these points are. If we're going from pi and shifting that pi over 4 units to the left, then we need to figure out what pi minus pi over 4 is. In this case, plugging this guy in here, we want to get a same denominator. So we'd have 4 pi over 4 minus pi over 4. So this would be 3 pi over 4. Just right about there. Similarly, we want to do the same thing for 3 pi over 2. We'll get 3 pi over 2 minus pi over 4. This will give us 5 pi over 4. And lastly, 2 pi minus pi over 4 is going to be 7 pi over 4. Doing the same thing on this negative x-axis here, we'll get minus pi over 2 minus pi over 4. So we'll get minus 3 pi over 4. And we'll have minus 5 pi over 4 and minus 7 pi over 4. So all of these points are going to be shifted over. So for example, this pi over 2 is going to be shifted over here to pi over 4. This point here at pi is going to be shifted to 3 pi over 4, and so on. Now connecting these points, we'll get this graph here. So that's how we would graph this function by using our horizontal translations. All right. Now let's do the same thing for this example here. First, what we'll do is identify everything. So we can see that our amplitude here is going to be 3. Our period is going to be 2 pi over b. In this case, b is 2. So our period is going to be pi. We also see that our graph is going to be translated pi over 6 units to the right, since we have minus pi over 6. So d is going to be pi over 6. And then c here will be positive 4. It'll shift our graph 4 units up. So the first thing here, following this procedure, is we'll graph our function of this form. So we're going to want to graph this guy first, and then use our translations. So we know that our period is going to be pi. So what we do here is break up that period into 4 equal parts on both sides here. So doing so, we get this guy and this guy here. Now we want to evaluate our function at these points. So first, let's evaluate this guy at f of 0. Doing so, we'll get 3 times cosine 0, which is going to be 3. Evaluating at pi over 4, we'll get 3 cosine 2 times pi over 4. In this case, we'll get 3 cosine of pi over 2, so this will give us 0. Doing the same thing for pi over 2, we'll get 3 cosine of 2 times pi over 2, which will give us 3 cosine pi. Cosine of pi is going to be -1, so we'll get -3 here. Do the same thing for 3 pi over 4. So this will give us 3 cosine of 3 pi over 2, which will give us 0. And then the last one we'll do is pi here. This will be 3 cosine of 2 pi, which gives us +3. Alright, so we'll graph these guys. So we said at 0 we'll get 3 here. Pi over 4 was 0. Pi over 2 is -3, 0, and pi would be 3. Similarly, on our negative x-axis here, at pi over 4 we'd get 0 or minus pi over 4. At minus pi over 2 we'd get -3, minus 3 pi over 4 is 0, and minus pi will get 3. So this will be our graph, 3 cosine 2x. Alright, now we know that we want to move this graph pi over 6 units to the right and 4 units up. So the first thing that we're going to have to do is translate all of these points pi over 6 units to the right. So at this point we'll move over here, pi over 6 units. This guy will move to the right here, so we have to find this point, pi over 4 plus pi over 6. Doing so, we'll get 5 pi over 12. That'll be this guy here. We want to move this point here, pi over 6 units to the right. So we'll have pi over 2 plus pi over 6. This will give us 4 pi over 6, which we can simplify to 2 pi over 3. So we'll get 2 pi over 3 here. So make this a little nicer. Repeating this process, we get 11 pi over 12 here. Now doing the same thing on the negative x-axis here, this point here is going to move pi over 6 units to the right here. So we'll do minus pi over 4 plus pi over 6 here. Doing so, we will get minus pi over 12. Doing the same thing for this point here. So this guy is going to move pi over 6 units to the right here. For this guy, we will get minus pi over 3. Doing the same thing for this point here. We'll get minus 3 pi over 4 minus pi over 6. Doing so, we'll get minus 7 pi over 12. And lastly, moving this point, pi over 6 units to the right, will give us this point, minus 5 pi over 6. Alright. This point will be here. We have a point here, 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 and here. So connecting these guys will give us this graph here. So this is our graph translated pi over 6 units to the right. And then the last thing we want to do is then translate that graph 4 units up. So we'll do that in this color here. So for example, this point here is going to be translated 4 units up. So right about there. This point here, 4 units up, is going to be right about there. Repeating this process. This point needs to go 4 units up, so right about 1. So maybe right about there. This point will go 4 units up, so right about here. And then repeating this process for the negative x-axis here. So our graph will look something like this here. Alright. So that's how we would graph a function of this form using our vertical and horizontal translations. Now the last thing we're going to do here is look at this example. We're given this graph here, and we're told that the function graph is of this form here, or this form, where b is greater than 0. So what we want to do is use this to determine the equation of the graph. So the first thing we'll do is write down our given information from this graph. We can see here that our amplitude is going to be 5. So A here is 5. We also see that one period here, which looks like that here, is equal to pi. So since our period is equal to pi, this tells us that b must be equal to 2. Since remember, our period is equal to 2 pi over b. And if b is 2, then we get that our period is pi. We also know that this is going to be a sine function. It's of that form here where it's an odd function passing through the origin. So this tells us, with that information, our equation will be 5 sine of 2x. Alright, so that'll be it for this video.